All right, welcome to class number 4. We're going to talk about functions and modules, and we are on the first module for this one, so we are defining and calling functions in Python. All right, without further ado, we're going to go ahead and jump into our class 4 workbook in our Jupyter Lab. So we're running Jupyter Lab. Make that full screen. That's part of the Anaconda project, so if you're joining us now, I do recommend you go back to the beginning and watch the whole lecture series. But if not, you can download and use Anaconda, where I go over installing all that, and we're running Jupyter Lab out of that. Now you can run this in something like PyCharm or VS Code or something else that does Python as well, but I just like to have everything self-contained where I can have my notes, I can actually run the code, and we can just have it all in one place. Plus, Jupyter Lab comes pre-installed with a bunch of libraries that we're going to talk about when we get to modules 3 and 4 of today's class. All right, so one thing I want to point out when we're talking about functions in Python and why we use them, it helps us take big problems and put it into these smaller digestible chunks of code. And these allow us to do reusable bits of code, such as if I want to take the average of a series of numbers, or maybe I need to do that 3 or 4 times throughout my program. If I've encapsulated it into a function, I will just call and do that function each time I need to do it. So I write the code once and then call it whenever I need to do that particular bit of code. Some other programming languages call that a subroutine. In Python, we tend to call them functions if they're by themselves, or methods if they're inside a class. And we'll talk about object-oriented again on class number 6, I believe, is object-oriented, right? So yep, the second half of the class, we'll talk about object-oriented. So we'll learn the difference between methods and functions. But in actuality, there's no difference for how we define them. We're going to use this def keyword. So you can just say the word def, which is short for define. And you'll see that it gets us that dark green in Jupyter Labs, indicating that this is a reserved keyword for Python. So I'm going to give it a name. Let's do our example. Let's do average. We're going to do an average and return back or we're going to print out some average result. So I'm going to have my method. It's going to open and close parentheses, and I'm going to end it with a colon. Just like we've seen with for loops and if statements, we end it with a colon. And whenever we end with a colon, we know the next section of code is going to be what's called a code block. It's going to be indented 4 spaces, and everything that's indented 4 spaces is all part of that code block. And that's actually called, in this term, it's called the function's body. So this code block that's part of the def average function is going to be, the code block here is going to be the code's function's body. So we have the first line, which is called the definition. We're defining it. And then the next several lines of code are going to be the function's body. So let's create a list here, and we'll just say the list is numbers 1, 6, 8, I don't know, 3, 5, 9, I don't know. So just give a bunch of numbers. We're going to store that in some variable called nums. Actually, we'll call it list of numbers. And I did periods and I meant to do commas. So bear with me while I'm fixing my code there. All right, so what I've done here, if you go back to the previous class, you'll learn, we'll talk about data structures. You'll learn that this is how we create a list. I can do the constructor call where I have the open parentheses, close parentheses, and give it a series of things, or I can do it with square brackets. And that's the more traditional way, but I wanted to show you that we could probably do it both ways. In this case, I've got my list of numbers, and I'm going to calculate the average. So what I really need to do is loop over all of these numbers, summing them up, and then dividing by the total number of items there are. In this case, there's 1, 2, 3, 4, 5, 6, so we need to divide by the number 6. We should be able to get the length of our list of numbers, and that should give us the number 6. We'll just do our test code here real quick, just to make sure that that's what we get. Put that into our print statement, and we'll go ahead and run this just to make sure we're getting the value of 6. oh, I haven't got the value of 6 because actually I forgot to tell you that when we define a function, it doesn't actually run it. All it does is puts this in memory, so when somebody else wants to use it later, they can just call it. So I have to actually end up calling it here, just to run it that way. And we do get the value of 6. Okay, so we're on the right track. We got the length, or the, yeah, we'll call that the length of size is equal to the length of numbers. Now I've got to get the summation of all of them. And I'm going to do list comprehensions, because that's always fun, right? I could do a list comprehension. Well, we'll do it in a loop. For I in list of numbers, I'm going to say count plus equals I. And I've also got to define count outside of my loop, so count is equal to 0. And at the end of this loop, I've gone over each of my items, and I've incremented it, count, by that number every time. Remember, count plus equals I is the same thing as writing count plus I. So I'm storing the result in count of the summation of the previous value of count plus the new value that I'm looping over. So in the end, I get the summation of all the values in my list. Now let's go ahead and print out the average is, now we learned about F strings last class, so I'm going to reincorporate that F string concept where we put the letter F in front of our quotes, and then we can put curly braces in here, not defining a dictionary or a set, we're defining a block of code that's going to run inside our string. And the block of code is going to be count divided by size. And we'll go ahead and run this, and we'll see the average is 5.33333. Let's take this over to Excel, just for fun, just so I can show you that our calculation is correct. I'll open up my Excel, bring that over to this screen, and we're just going to put this list of numbers here. Let's put them, let me see if I can make this a little bit bigger, right? Okay. So I'm going to say 1, 6, 8, 3, 5, and 9. And then if I sum over them, it tells me the count is 6, the sum is 32, and the average is 5.33333. So our logic is correct. So now we have a way to calculate the average of a list of numbers. So we've defined the function using the def keyword, and then give it the name, followed by open, close parentheses, and then a colon. That gives us our definition. Then the block of code that's indented 4 spaces, that is our function's body. So our functions are usually, I mean, they can be long, but you want them to keep them as short and precise as possible because you want them to be one idea or one concept that we can reuse elsewhere, right? So I want to make a big idea broken down into these smaller parts. So these smaller manageable tasks should be maybe 10, 15, maybe up to like 25 lines of code. But other than that, then you probably could break that 25-line function into some smaller functions as well. So we want to take this idea of single use, single concept idea. Okay, I had to call the function, so I had to jump ahead because I wanted to show you how it worked. But to call a function, we'll grab this same set of code down here, copy it down below to our calling function section. To call a function, you simply write the function's name followed by parentheses. That's what we did. And it's outside of the code block, so therefore it's part of the main program, right? So we're calling the average function right here with this line of code. Now we'll talk about parameters here in a second, but I want to show you something else that's important. I mentioned that this line of code here is the definition. The definition has to happen before we can actually call on the function. So in other words, if I had another function, let's call it def test, just giving it another name, and all I want to do here is print this is a test, and I try to call test here, I'm calling a function that Python interpreter doesn't know exists yet, because it starts at the top, works its way down. In fact, it starts at the top because this is a top level thing. It's not indented. It says, okay, I've got this definition. I'm storing that in my memory. Then it's not going to run any of this code because it's indented. It just puts this in memory. Then it comes down and says, oh, okay, I look in my memory. It's calling average. I know where that's at now. I'm going to bring it back up here and actually run this block of code. But when I get to test here, it looks in its memory bank and says, I don't know test exists. Where does test live in this program? I don't know the location of it. So I'm going to get an error if I try to call a function that doesn't exist. In fact, it'll say the name test is not defined, and we get a name error. A little bit of more foreshadowing for our next class when we talk about error handling, right? There's different types of errors. In this case, this is a name error. In order to fix it, all I've got to do is move the definition of test above. And now it should work just fine, and it does. Right? So test prints out, this is a test. Okay, so one other thing I wanted to point out for this video is this concept of docstring. Now, not a requirement by any means, but this is a best practice or a good thing to do, is to put a docstring in the first line of your function to tell everybody what's going on with this particular function. This helps others when you come to look at a function, what's really going on. In fact, we're going to go ahead and copy this function. Actually, we'll just copy this whole set of code, bring it down here, and I'll show you how to do a docstring. Straightforward. You know what a regular string looks like. This is a regular string. Docstrings just do 3 sets of double quotes. And the cool thing about docstrings is they can be multiple lines. So I could say this is a docstring, and it starts with 3 double quotes and ends with 3 double quotes. And until it gets that end, it's all part of one string. So what I could do here is put a nice warning for people that are going to use this. This method or function gives the average of a predefined list of integers. All right, so now when I come back a month from now, I'll kind of have an idea of what this function is supposed to do. So that's really what I wanted you to get out of today's class, understanding why we do this. It takes a big concept, we break it down into manageable bite-sized chunks that is reusable. For instance, I might need to take an average 4 or 5 times in my program. If I've got a function that all it does is calculate averages, now I can use that set of code later on, and I only have to write it once. I can just reference it, and it'll give me that block of code or that function's body whenever I call it. All right, so how do we define a function? We use the def keyword, which is a reserved keyword in Python. So def space the function name, whatever we want to give it. I could say average, I could say calculate, I can't spell, calculate average. Whatever I want to give it the name. This is my name. Just like with the variables, I can call it, and usually I call it with lowercase. And I always separate words with underscores. That way you can kind of see what it's saying there, right? So that's how I'm defining my calculate average. And every programming language is different and uses different coding styles. With C# and C-based languages, I usually follow the Pascal casing. So I would say something like calculate average. I don't use underscores, and I use capital letters to identify words. So it's just a paradigm, whatever you choose to do, just make sure you stick and be consistent. It tends to see, when I look at Python code, how do I control Z? Yeah, there we go. What I tend to see in Python is this underscore casing with lowercase. That's just the standards that I see most often. So that's what I'm going to try to type here, but I may revert back to my days of being a C# programmer. Okay, so takeaway. We have to define a function before we use it. The function is a concise one concept idea, calculating average, pinging a computer, whatever that one concept that it's supposed to do. And it should be between, I don't know, 3 or 4 lines of code all the way up to maybe 20 lines of code. If it gets bigger than 20 lines of code, you can probably break that one function down into multiple. And then we call a function after it's been defined by referencing it by its name and open and close parentheses. So for instance, what do you think print? Do you think print is something that's predefined, or is it actually a method? And it's actually a function, right? So it's got a name, it's got open and close parentheses. Now this one actually takes in parameters. I can put something inside the parentheses here, and we'll see that next class. But I just wanted to show you that print is no different than any other function. And we also have seen other ones out there, such as type. So this type is also a function. So I encapsulate the word test, and that gets passed into my type function, and then my type function gets passed into my print function. So I can embed functions inside of each other. I should be able to do that here as well, right? I don't know if this will actually work, but we'll try it because it's not really expecting anything. Yeah, it gave me an error because it's not expecting anything. If I take something in here, we'll just say test. There we go. So the first thing it does is calls this inner one, called this is a test, because it does the inner function call first. Then it does the outer function call, and that's why we get the average afterwards. So before, when I had test below, and I'm just going to put none in here because I told it that it's supposed to take something. You'll see that it prints the average first and then prints out the test. So I can embed functions in other functions, and so that's just something that we'll have to learn the syntax of, but it's perfectly valid syntax. It just looks a little funky. All right, with that, that's the good takeaway. Next class we'll talk about the parameters and return values. We got a little bit of a peek with that when I had the average take in a variable here, test. I did nothing with it, but we'll see how that works next class. All right, I'll see you in a few minutes. Take a break. Come back in a few minutes.